Hello friends, in this video we will study motion of a charged particle in an electric field, in an uniform electric field. So let this be the positive plate of the field, and here is negative plate. So this is uniform electric field. In between them, this is the direction of field from positive to negative. Let the length of the plate be x. Now here an electron having charge E negative and mass m entering this field with velocity v0. So had there been no field, this electron would have traveled in the straight line with this v0 velocity. But since it has negative charge, so positive plate will attract it, and its motion will be like this somehow. So from its original path, it will show a deflection. Let us name that y, and also it will emerge here with some angle theta. We have to calculate this deflection of it from its original position and this angle theta at which it emerges. Now for this we have to consider the motion of this electron in two directions, x-axis and y-axis. So here is x direction motion, here y direction motion. Same case in the way we do in projectile to calculate the Hmax range and time period, etc. See, initial velocity in x direction, we throw it straight with a velocity v0, so initial velocity in x direction is v0. Now acceleration in x, there is no force on it in the x-axis direction, so there is no acceleration in x direction is 0. Let us suppose time to get from here to here t. Displacement in x direction, total distance traveled is the length of this plate x, SUAT. So we will apply, since it is a case of constant acceleration, so we can apply S is equal to ut plus half at square. So displacement in x is x, initial velocity is v0, acceleration is 0, this term is 0, so it is v0 t. Time here is x upon v0. So in the time t, it reaches from here to here in the x-axis direction, and in the same time it shows the deflection. So time in y direction is, for y direction motion, time is also x upon v0. Displacement in y direction, total displacement in it did y, the deflection. Now see, now we have to calculate acceleration in y direction. Now the total force on this, force in the electric field is always QE, charge times the electric field, and charge here on this electron is E, electric field is E, so E is the force. So the acceleration this positive plate will apply on it is force upon mass, so force is EE upon mass of the electron is m. So acceleration in y direction is EE upon m. SE. Now initial velocity, there is no initial velocity in y direction as we throw it straight, so initial velocity in y direction is 0. Here also we will apply the formula, S is ut plus half at square. Displacement is the deflection, initial velocity is 0, so this term is 0. Now half acceleration is EE upon m. T square, T we got here, it is x upon v0, so it is square is x square upon v0 square. This is the deflection, total deflection of this electron, and it depends upon the charge upon mass ratio. So greater the charge upon mass ratio, greater the deflection, less the charge upon mass ratio, less the deflection. Now we will try to calculate this angle theta. So in their initial velocity in this direction was v0, and here it was 0. Let final velocity here will be vx, and towards y direction let it be vy. Now this is vx, this is vy, and here is angle theta. We can shift this vector here, so this is vy. Now applying formula v is equal to u plus at for both directions. Vy is uy plus at. Final velocity in x direction, we don't know that. Initial velocity is v0, acceleration is 0, so this term is 0. Now here final velocity in y direction, we don't know that. Initial velocity in y direction, that is 0, and acceleration is e upon m. Time is x upon v0. So now tan theta here is vy upon vx. So tan theta is vy upon vx. Vy is e upon m, x upon v0, and vx is v0. Vx is v0, so it will be v0 square here. Now this tan theta also, angle at which it emerges, also depend upon charge upon mass ratio. So these are the two things we got. One is the deflection, and the another is angle at which it emerges.